In this video, we're going to be exploring the properties of exponents, but we're going to focus primarily on exponents that happen to be rational exponents. So recall really quickly, if I have you look at my properties of exponents here, these bottom two statements down here, when we talk about properties of exponents and how they apply, we've been getting into expressing radicals like the nth root of a here. We say the nth root of b. We've been expressing these instead as like a to the 1 over n power times b to the 1 over n power because they are both to the nth root, so that would be their denominators, but these are both a to the first power and b to the first power, so those are the powers. So if we're dealing with things like this, we can make some really common statements about them, but kind of reviewing our properties of exponents, let's go ahead and revisit these. We say if you multiply two things with the same bases, then you would add their exponents, whereas like if you were dividing, we say a to the m over a to the n, you subtract their two exponents and the base stays the same, okay? Likewise, we say if we take a power to a power, a power to another power, we multiply the two exponents. And then we built on these. We said, a power of a product, if it's a times b to the m, then we have to take everything in here to the mth power. If we had a negative exponent is what this says, we need to move this downstairs to the basement to make its exponent positive. This says that anything to the 0 power is equal to 1, okay? So last but not least, I guess we have this power of a quotient, which says if you take a fraction to a power, you have to take both parts of the fraction, all of the top and all of the bottom of that power. So that being said, we're going to use these properties like we've done in the past to kind of evaluate or at least simplify these expressions over here on the right that contain rational exponents. So for instance, we say 5 to the half times 5 to the 1/4. Now I want you to imagine here, if I had like 5 to the second times like 5 to the 7th, of course we would say, well, then I'd have 5 to the 9th. All we're really doing is using this product property that says I would add my exponents. So what this does is it requires some side work since we're dealing with rational exponents. I need a common denominator here. So if I multiply the top and bottom times 2, I get 2/4 plus 1/4. This is to the 3/4 power. So instead we get 5 to the 3/4 power. And as a matter of fact, just as a matter of practice, we say this is a perfectly okay answer. But I would also say that this is the same thing as 5 to the 3rd power, the 4th root of that, or some, if you did this on a calculator, you say it's the 4th root of 125. I just wanted to re-mention that those mean the same thing. Okay, so over here, if I'm going to evaluate this, I notice that I should probably start inside the parentheses, and I am multiplying two things with the same bases. So what I'll do instead here is I'll just say that it's 8 to the 1/2 plus 1/3. So I say 1/2 plus 1/3. That's what I get, and we're taking all this to the second. So we say half plus a third would be the same thing with the common denominator of 6 would be 3/6 plus 2/6. So we get 5/6. So I would say that this is 8 to the 5/6 power. It is all to the second power. So now, if I were to say power to a power, this is our second property. It says you need to multiply your exponents. So we're going to need to take 5/6 times 2 over 1, which actually we can reduce this. We say 1 and a 3, but we get 5/3. So we get 8 to the 5/3 power. And this would be our evaluated expression. And again, we could write this as 8 to the power of 5, the cube root of that. Okay, so again, this same property is being utilized over here on the right, but what I want to kind of point out here is this. I notice that I have a product here, so 2 to the 4th times 3 to the 4th, and this is all to the negative 1/4 power. A product to a power means we could actually send this through, we could distribute this through, and say it's 2 to the 4 times negative 1/4 times 3 to the 4 times negative 1/4. And the only reason I mention this is because negative 1/4 times 4 actually comes out to just be negative 1. So in this case, we get 2 to the 4 times negative 1/4 is negative 1, times 3 to the 4 times negative 1/4 is negative 1. So we get this expression. So we'll just simplify this by saying, well, this would be 1 over 2 to the positive 1 times 3 to the positive 1. So we get this. We get a 1/6. All right. So let's go ahead and finish up these last two. We get 7 divided by 7 to the 1/3. This is our quotient property here, but remember it said dividing two things with the same bases. You're going to get the same base, but you're going to subtract the exponents. So we get 7 to the 1st power minus 1/3. So we'd say 1 minus 1/3. If we did this 1 whole minus 1/3, of course, is 3/3 minus 1/3. We get 2/3. So we'd get this. We get 7 to the 2/3 power, or we could say this is 7 squared, the cube root of that. We could say that these mean the same thing. And last but not least, I notice I'm taking a quotient to a power here. So this one's it's going to involve a little bit of manipulation here. But what I want you to notice is this. These do not have the same bases. This is very important. But they have the same exponents. So we're going to pull a little bit of sleight of hand here, but we're going to write it this way. We're going to say 12 over 4 to the 1/3, all of this to the second. And what I want you to see that I've done is this. I notice that because both of these have a 1/3 exponent on them, what we could do is we could really, right, we're using this power of a quotient property here backwards. We say if it's a to the m over b to the m, this is a over b to the m. I kind of took this exponent up here to the top. And the nice thing about this is, well, we know 12 over 4. 12 over 4 is actually 3. We have 3 to the 1/3. All of this is being taken to the second. So now I've got power to a power property going on, and 2 times a third is 2/3. So this all together, we get 3 to the 2/3 powers, our evaluated expression. Or we could write it like this. We could say this is the same thing as 3 to the second power, the cube root of that, or the cube root of 9. Okay, so that is how we're going to use our properties of exponents with rational exponents.